Alright, today we're talking about trigonometric ratios, or just trig ratios for short. The objective, I will learn to use trigonometric ratios to find side lengths and right triangles. And we're going to start by defining what a trig ratio is. And that's just the ratio of two sides of a right triangle. And you got to focus, this is going to be based on the acute angles. So if I have this right triangle here, triangle ABC, and C is going to be my right angle. So I can use these trig ratios either using angle A or angle B. All right, and I'll show you how in a few minutes. Let's kind of define these. There's the three most common ones that we have are called the sine, cosine, and tangent ratios. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So sine of A, so I'm using this triangle here. All right, sine of A, so if this is my reference angle here, the leg opposite that is going to be A. So this would be A over the hypotenuse, which is C. Okay, this is going to be the hypotenuse, so that would be my lowercase c. The cosine is going to be the ratio of the length of the leg adjacent to the angle and the hypotenuse of the other leg. So if I'm using A still, the leg that's adjacent is going to be B, and my hypotenuse is still C. So this ratio is going to be B over C. And then for tangent, that's opposite leg over adjacent leg. So again, I'm using A as my reference angle. So I go across for the opposite. That's going to be A as my numerator. And then my adjacent leg is B. Okay. Something we use to kind of help you remember this is called SOHCAHTOA. All right. Where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we call that SOHCAHTOA. All right, so now let's look at an example using these three trig functions. All right, and I want to find the sine of A, cosine of A, tangent of A, and then I want to find the sine of B, cosine of B, and tangent B. So I have this right triangle here. Sine of A is going to equal the opposite over the hypotenuse. So that's going to be 5 as my opposite of A. And then the hypotenuse is 13. All right. Cosine of A then is going to be adjacent over hypotenuse. So if A, the leg that's next to A is 12, and the hypotenuse is 13. All right, then we got the tangent of A, which is opposite over adjacent. So opposite would be 5. My adjacent would be 12. All right, now if I switch this over, and we want to look at using B as our reference angle, so we got sine of B. That's going to change things because now what's opposite of this angle B is the 12. So for sine, that's going to be 12 over 13. Cosine of B is going to be adjacent over hypotenuse. So if I'm at B, the leg that's next to that is 5. Hypotenuse is still 13. And then tangent is going to be opposite over adjacent. So if I'm at B, across from B is 12, and adjacent is 5. All right, next example, we're going to use these two angles here, S and E. Those would be my acute angles. So the sine of S is going to be opposite over hypotenuse, so that's going to be 3 over 5. The cosine is going to be 4 over 5. And the tangent would be 3 over 4. All right, I'm going to let you do the sine of E, cosine of E, and the tangent of E. I'll leave that up to you to finish that off. All right, because I want to talk about special right triangles. Remember we had these, if I have a triangle, and I know this is 90, and I know one of the angles is 30, the other is 60. And then we had, because special right triangles, there's a pattern, there's a formula. This was x square root of 3, and this was 2x. All right, so if I want the cosine of 30, all right, that's going to be adjacent over hypotenuse, so that's going to be x square root of 3 over 2x. My x's are going to factor out, and so the cosine of 30 degrees is actually going to be the square root of 3 over 2. Okay? We'll try that again. We're going to look at the other special right triangle, which was a 45, 45, 90. That looks more like this. All right, on this one it was going to be x, and x square root of 2. All right, we want the sine of 45 degrees, which is going to be opposite over adjacent. So if I'm at this 45, it doesn't matter which one I use because they're both the same. But opposite would be x, and then hypotenuse is going to be x square root of 2. Like the other example, the x's are going to factor out. That's going to leave me 1 over the square root of 2. But remember, we can't have a square root in the denominator, so I have to multiply both top and bottom by the square root of 2. So the sine of 45 degrees is going to be equal to the square root of 2 over 2. All right, now here comes the easier part, I guess. So you're going to use the calculator for this to find these ratios here, since they're not any of these special right triangles. I do need to caution you, though, that the thing you have to make sure that you do is you have to go to the mode button, and you have to make sure that it is not on radian. The calculator has to be set to degrees, otherwise you're going to get this wrong. So always, anytime you're using these trig functions, make sure that you're on the degree feature. Again, you have to hit the mode button and then go down here to the third line and check to make sure that degrees is selected. Okay. After that, all you have to do is put this in the calculator. So you would just hit the sine button, which is kind of towards the center of the calculator here. All right, and then all you have to do is just hit sine of 52, and you want to round this to the nearest hundredth place, so that is going to be 0.79 for the first one. Then the second one, you just hit cosine, which is right next to the sine button, of 19. All right, rounding to the hundredth place is going to be 0.95. And then tangent of 65 is going to be 2.14. All right, that's it. When it gives you to use your calculator, it just gives you the sine of some angle or the cosine of an angle, tangent of an angle. You actually just put this in the calculator. All right, this last set of examples is going to actually let us use the trig ratios to find the missing side lengths of a triangle. So if I have these examples here, where I want to find this side that's missing x, and I want to use my trig functions to actually come up with an answer for x. Right? So I want to use, since they gave me the hypotenuse, I'm going to use this function here. I'm going to use the sine function. So the sine of 21 degrees is equal to opposite over hypotenuse. Okay, so this angle, this would be my equation. The sine of 21 degrees is equal to x over 9. All right, now we need to solve for x. All right, so since I have this fraction here, I want to get rid of the denominator, so I'm going to multiply both sides by 9. Okay, these factor away. So on the calculator, all I need to type is 9 times the sine of 21. Okay. Again, for all of these, I want to round to the nearest hundredth place, so I'm going to say that this is going to be 3.23. All right, so let's do the same thing with example B. All right, I want x. Same thing here. Just to show you that you can use any trig function, I'm going to go ahead and use cosine on this one, since I do have the hypotenuse. So I'm going to say the cosine of 37 degrees is equal to adjacent over the hypotenuse. Right. So now to solve for x, I'm going to multiply both sides by 13. So cosine of 37 is equal to x over 13. I want to get rid of my denominator. So I multiply both sides by 13. And those factor away. X is going to be equal to 13 times the cosine of 37 degrees. All right, rounding to the nearest hundredth place, that's going to be 10.38. All right, this next example, if you notice, there's only one side that's given to me, one side and an angle. So this is going to kind of make it a little bit more involved, but not too difficult, I don't think. So let's look at my options here for x. I know x is my hypotenuse because it's across the 90. And this 8 is next to or adjacent to the 54. So that looks like a good spot for me to use the cosine function. So this is going to be cosine of 54 is equal to adjacent over hypotenuse. All right. Now this time what's going to happen is that x is my denominator. So I'm going to have to multiply both sides by x. Those factor on that side. Then we need to actually take, since I have x times the cosine, it's actually going to be x is equal to, then I have to divide both sides by the cosine. So x is going to be equal to 8 divided by the cosine of 54. So then on here, I just hit 8 divided by cosine of 54. Close my parentheses. That comes out to 13.61. Right, and then if I want to use the y is opposite the 54, and still the 8 is still coming into play. So I'm going to actually use the tangent of 54, and that's going to be opposite over adjacent. Okay, so again, to solve for y, tangent of 54 is equal to y over 8. I'm going to multiply both sides by 8. Those 8's factor out, and so y is going to be equal to 8 times the tangent of 54, right? And that comes out to be 11.01. Okay, the last little example D here, I'm going to leave that up to you to do.